Hello there, this is Jeffrey Matthews, the physics tutor, and I'm here to go over a few concepts, and I hope you find this helpful. So, to begin with, I want to talk about this universal approach to physics problem solving that I usually discuss with kids and students of physics. It's the 3 or 4 step approach, depending on how you go about it. So I would suggest the first thing you do is, as soon as you get a problem, and this is geared towards problem solving in particular, this video. You get a problem on a quiz, on an assignment, on a test, and the first thing you want to do is you want to read through that problem, and the first step that you want to take is you want to write what's given to you. And that's basically taking out all the words, instead using symbols or a more condensed form of understanding of the data in the problem. So the given discusses the data, and it just lays it all out there. And so if you had a question which said a ball is thrown with a velocity of 12 meters per second, so I would say velocity is 12 meters per second at an angle of inclination or to the horizontal at 45 degrees. What distance does it travel in? What distance has it traveled in time in 5 seconds? So that would be my t. So that's all the given information. That would be my first step. My second step would be what is being asked. So in this case, it's what is the distance. So that's usually referred to with the variable x, or whatever it is that you're comfortable with, d, whatever works for you. So you have the first 2 steps down. Third step would be what is the formula, or what connects the given to what's being asked. So I asked myself, okay, what formula ties up all of these? And with some practice and exposure and practice to the kinematics equations, we would know that the horizontal distance traveled by a projectile is the x component of the velocity times the time. And this is just it's just the application of the basic formula, which is distance is velocity times time, or velocity is distance over time, however it is that you can easily remember it. And so now we have a formula that connects the first to the second, and so that gets you the answer, basically. But this is a very simple question. So now what if you had a little more complex question where you don't get the answer in one step, but instead you have to find an intermediate unknown and then use that to find the answer? So then you would have a 4th step. So in the 3rd step, you're asking yourself what connects the 1 to 2, and so what is x equal to in terms of v, theta, and t? Or sometimes you don't need all of the information provided. Sometimes you need to read between the lines and get numbers or data that isn't very clearly stated. We can elaborate on that in a different video. So then in your 3rd step, when you're trying to find the connection between 1 and 2, you might not find one formula that gets you from 1 to 2, or that relates all the variables in 1 and 2. So in such a case, you'd have to use an intermediate formula, or a formula that gets you to a 2nd step, and then from there work towards the answer. So that's a breakdown of the 4-step method, or the 3-step method, depending on how you look at it. And it usually works for a lot of the physics students, and works in general on a very general way. So now I'd like to discuss the 3 major equations in kinematics, and give a breakdown of how to approach them and how I look at them and how I think it'd be useful to students. The first step would be the first equation we usually discuss is velocity equals so that's final velocity is equal to initial velocity plus acceleration times time. Then we have distance equals velocity time plus half at squared. And then we have v squared equals v initial squared plus 2a delta x or s, depending on the textbook you refer to. So The first equation is an equation with no distance in it. There is no x. So if you have a question which directly relates only the final velocity, initial velocity, acceleration, and time, you can use this equation. But the key point here is that there is no distance here. And so that the first equation in general in physics classes you find a lot of application to. It's also one of the faster equations and easier problems to solve. You usually use these equations, use that equation. The second equation, you do not have final velocity. It is not there. So there is no final velocity. Instead, you have the distance, the velocity, acceleration. So in the first, we have a relationship between velocity and time. And in the second equation, we have a relationship between distance, or x, and time. This is a simplified way to look at it. And finally, in the third equation, when you don't care about time, there is no emphasis on time, or you might care about time, but not at least in that step, in a certain step in problem solving. Then you go for the third equation, and that's the equation that relates the final velocity, or the velocity, to distance. So first equation is velocity and time, no distance. The second equation is distance at time, no velocity. And the third equation is velocity and distance. I hope you find these videos helpful. Hit me up if you have further questions or if you'd like me to elaborate. Thank you.